All right, so these are the problems from day 2. I'm going to go over a few of them. It says, in a game of 10-pin bowling, Zhu has 29% chance of getting a strike. If it takes 4 games, x equal to 4, until he gets a strike, what happens the first 3 times? He wins on this last one. So he has a 0.29 on this, 0.71 here. So that's going to be 0.71 to the third times 0.29, whatever that one is. You guys good with those? And then the next one we're going to do is find the probability that Zhu will take 7 bowls. If you could have it quiet, please. Thank you. 7 bowls to score 3. So in this case, your x is equal to 7, and you have to have 3 wins. Okay? So we don't know what happens on the 6 games. We know that there's 2 wins, but we don't know where it happens. So we're going to find all the combinations of where those 2 wins can happen in 6 games, times the probability, which was 0.29, to he needs to win a total of 3 games, and 0.71, you're going to lose 7 minus 3, which is 4. Now, if that confuses you, what it is it's 7 minus 1 minus, this should be 1 here, excuse me. 3 minus 1, minus 3 minus 1. Is this the same as 7 minus 3? Yeah, because what happens to the negative 1 and the positive 1? They cancel. So that's why I pulled that fast one on you there. You can see that. And then whatever that works out to be. Let's try the next one. You try this one. All right, let's see how you did with this one. From past experience, Fred has a 72% chance of driving a golf ball in excess of 230. Find the probability that Fred needs 5 drives in order to hit 1. So there's x is going to be equal to 5. So how many times is Fred going to not make it? 4 times. And then how many times is he going to make it? Once on the last one. So there you go, whatever that is. Fred needs 12 drives in order to exceed 234 times. So you go, I would go x equal 12, and we need a total of 4. So we don't know what happens the first 11 to get the first 3, but we know that 0.72, he's going to need a total of 4. If you wanted to think of it this way, he's going to sometime or the other make 3, and then he's going to miss 2, 8. Yeah. He's going to miss how many times? 8. And then on the last one, he's going to make it. So we just simplify it for ourselves and just say, oh, he's going to make it. 0.72 to the 4. So we don't know what happens the first 11 games. We know he's going to win 3, but we look at all the combinations of making it 0.72 to the third times 0.28 to the 8th. And then the last one we multiply by is the win. This one I'm going to leave up to you to figure out for Monday, but we're going to do number 4. The discrete random variable x follows the distribution, and it's geometric. Write down the mode. What value is it going to happen? So let's look at it this way. Let's say that Micah works on his game of throwing the ball into the basket. Not normal basketball, but this crazy basketball we did. And he improves his probability up to 0.80. Okay? Huh? It's pretty good. All right. So so this idea of, like, let's say x was equal to 1, that means the probability is going to be 0.8, right? But if it's 2, that means he does what on the first shot? He misses, and then he's going to make it. Well, how is this 0.16 going to compare to 0.8? Yeah, it's going to drive it down. How about this one? 0.2 times 0.2 times 0.8. What's going to happen to this one? Smaller yet. So the more shots he takes until he makes it, the probability of that happening is less and less. So when is he most likely to get the basket? On the first one. Weird, isn't it? But if you think about it, it makes sense. So the mode of this is x equal to 1. His highest probability is on that first shot. Mode is the most. Because, yeah. I thought we'd say pi. This is the way I tell students. Pi a la mode is way better than just pi. So it's the most. It doesn't help at all. All right, find the exact value of p if the variance is equal to 28/9. Just to give a quick hint, if you go back a couple slides here, you'll see that I have all of the formulas for mean and variance up here. And they are pretty fun to derive, but we're not going to do that here. For geometric, the variance is q over p squared, and the mean is 1 over p. So I'm going to write that down here, if I can remember it. The mean expected value is 1 over p. And what was the variance again? Q over what? P squared. Okay, thank you. They want to know what p is. So if the variance is 28/9 and the variance is 1 minus p over p squared, yuck, quadratic, right? 28p squared equal to 9 minus 9p. And put everything on one side. You get 28. Want something better here. 28p squared plus 9p minus 9 equals 0. Right? And so then, might have to use your calculator for this one. P is equal to probably plus, or let's see here. There sure is. -9 plus square root. But whatever that is. Are you going to do the negative of that? Are you going to do -9 minus? Does that even make sense? No. You're going to do the positive of it. Would you calculate that out for me, please? And it should be an answer greater than 0 and less than 1. I hope. Give me the 4 decimals when you get it. Did you get it? If you get 4, that's not good. All right. So let's leave that. I'll let you calculate that. Arthur tosses a biased coin each morning to decide whether he walks to school or bicycles to school. He walks if the coin is ahead. The probability of ahead is 0.5. So the probability of walking is 0.55, and the probability of cycling will be 0.45. Okay, find the smallest value of n, which the probability of Arthur walking to school on the next n days is less than 0.01. So all that they're doing there is they're saying n days. Just take your calculator. What's 0.55 times 0.55? What's that? Okay, 0.30. So we've got a ways to go. Times 0.55. Let's go 4 days. How about that? I mean, what's that going to be? I just need you with calculators, guys. 0.55 times 0.55, 0.55, 0.55. What's that going to be? 0.091. So we're going to keep going. Let's go another time. 0.55 is day 5. Times 0.55 is day 6. I'm wondering about 6. What is it for 6 days? 0.02. So let's try 7 days. Point what?
6 days is 0.027.
Okay, and then what's this one? 0.015. Did we make it? 0.015, is that less than 0.01? No, it's not. It's close, but 8 will do it. So you just do that with your calculator until you get it. Or if you wanted to do some actual math, it's 0.55 to the n less than 0.01. And let's just look at it equal. So you would just take log base 0.55 of 0.01 and set it equal to n. And what is that? The log of 0.01 over the log of 0.55.
7.7 and 8.
Yep, you go up to get to 8. All right. Find the probability that Arthur cycles to school for the 3rd time on the 8th day.
Oh, yeah, okay.
Come on, this is going to be a test of your knowledge.